tutorials for chemistry. We'll start with the new chapter here, that is Unit 3, Electrochemistry of Volume 1. So in this chapter we'll study about the redox reactions which occurs in galvanic cell, electrolytic cells and the conductance. And the conductivity, it is due to the flow of electrons. So let's begin. So what is oxidation? Just a general discussion about the definitions. So what is oxidation? So oxidation, that is loss of electrons. Correct? Loss of electrons and increase in oxidation state. Increase in oxidation state. And in simple words, we always say what is oxidation means addition of oxygen and removal of hydrogen. So let's write the definition for reduction. That is gain of electrons and decrease in the oxidation state. You can remember the words like reduction, reduce, decrease. So decrease in oxidation state. So these are the two definitions needed here. Electrochemistry, it is basically divided into three: electrolytic cell, galvanic cell. I'll just write here. It is electrolytic cell, the galvanic cell, and conductance. So we'll discuss about all the three. First we will start with the electrolytic cell. So what is electrolytic cell? We'll start with the discussion. So electrolytic cell which converts, it is a cell which converts electricity, that is electric energy into chemical energy. So first we are starting with electrolytic cell. Electrolytic cell, it is a cell in which conversion of electric energy into chemical energy takes place. That means we are providing electric current, right? And with the help of that electric current, a chemical reaction takes place. Okay, so what is the input here? The input is the electrical energy. That is the input. We have to provide electrical energy. And what is the output here? That is chemical energy, or we can say a chemical reaction will take place. A reaction will take place, that is the output. So, this electrolytic cell, the process which occurs, it requires electricity. It doesn't happen on its own. If the reaction, it occurs on its own, it is called as spontaneous reaction. But here, it requires electrical energy for the reaction to occur. So, it is non-spontaneous. So, it is non-spontaneous reaction. And as it is non-spontaneous reaction, delta G value, the Gibbs free energy G value is negative. So electrolytic cell, it is a cell in which conversion of electric current to chemical energy takes place. That means the input is electrical energy. We have to provide electrical energy and the output will be a chemical reaction happening. And it does not take place on its own. So it is a non-spontaneous process and delta G, Gibbs free energy, will be negative.
So an electrolytic cell is taken. Platinum electrodes are immersed into it. Okay, we started with the electrolytic cell which converts electrical energy to chemical energy. So we are taking an electrolytic cell, 2 platinum electrodes made up of PT. PT means the platinum electrodes. Why we are taking Pt here? Because it is inert in nature. So 2 platinum electrodes are immersed into the cell and both they are connected to a battery. It is connected to a battery. So one of the electrode, it will act as anode, positive, and one of the electrodes, it will act as cathode, which is the negative electrode. Now electrolyte, that means a solution which conducts electricity. Electrolyte, we are taking the example of NaCl, sodium chloride, and this sodium chloride, it is in the molten form. Correct? We know that in the solid form it will not conduct electricity. So it is in the molten form, in the melted form it is. Okay. Now when all the wire, everything it is connected, what will happen? Electricity will start flowing, and this NaCl, the electrolytic solution what we have taken, it will split into two. NaCl will split into Na plus ions and Cl minus ions. Correct? Ions are produced. So it splits into Na plus and Cl minus. Now positive ion will go towards the negative electrode and negative ions will go towards the positive electrode. So reactions at anode. Now remember this, at anode oxidation takes place and at cathode reduction takes place. So oxidation means loss of electrons. Okay. Now which ion is moving towards anode? Cl minus is moving towards the anode because it is negative, anode is positive. So Cl minus, anode oxidation, loss of electrons. So I will write it on to the right hand side, electron lost, and it is oxidized, Cl2. Correct. You can see the oxidation number also. Here it is -1 and it is here 0. Correct. Cl2, it is in the elemental form. So it is 0. So -1 to 0, there is increase in the oxidation state, right? And loss of electrons. I have written the electrons on the right hand side. Just to balance the equation, I will write here 2 Cl minus and 2 electrons. So you can see the Cl atoms are balanced and 2 electron, 2 electron. Correct? Now cathode reduction, that means gain of electrons. So which ion is moving towards the cathode? Na plus is moving towards the cathode. So I will write here Na plus. Right? It is gaining electrons. It is taking electrons, gaining. So this will reduce to Na. Here both sodium atoms, it is balanced. 1 electron minus and positive, 0 charge. Right? Charge is also balanced. You can see here the oxidation state of Na plus is +1 to 0. What happened here? +1 to 0 decreased. The number is reduced. So that is reduction. So loss of electrons, that is increase in oxidation state, oxidation, and gain of electrons, decrease in oxidation state, that is reduction. Correct? Okay. Now the anode equation what we have written, it is called as half oxidation reaction. Half oxidation reaction, because it is half only, right? And cathode reduction takes place. So we can write it as half reduction reaction. Okay. Next is representation of electrolytic cell. Electrolytic cell, how to represent it in an easy way, right? Instead of drawing the electrolytic cell, drawing the electrodes, mentioning that it is made up of platinum, right? What are the products formed at cathode, what are the products formed at anode? Instead of drawing and mentioning all these things, in a straight line, one line, we can represent the electrolytic cell. So let's see how it is. So first comes the anode, comma, anode product, correct. So this will be the positive side. Then we'll put a line between, we will mention the medium. That means the electrolyte, it is in which medium, whether it is in the molten form, whether it is in the aqueous form. We will mention the electrolyte used. We can also mention here the concentration and the temperature. If at all the concentration is 0.01 molar, then you have to mention. Temperature also, if mentioned, you can mention the temperature or you can write as high. Straight line. Then on to the right hand side comes the cathode product. First we will write the product and then we will write what is cathode made up of. I have written only anode and cathode, that means what it is made up of. So just now in the previous cell we saw no platinum electrodes are there, sodium chloride solution was taken, right? In the molten form it was taken as an electrolyte. So if we want to represent that cell in this form, we can represent it as, what was anode made up of? It was made up of platinum. Correct? Okay. What was the product at anode? Correct, oxidation took place. So the product at anode was chlorine gas, Cl2. Then one line. What was the medium? It was molten. What was the electrolyte used? It was NaCl. Concentration, temperature, if it is mentioned, you can in some other examples. And cathode product, what was the product at cathode? It was sodium. And what was cathode made up of? It was made up of platinum electrode. So this is how you can mention here or represent an electrolytic cell. So this you have to remember. First comes the anode and the anode product. Then comes the medium, electrolyte, concentration and temperature, cathode product and cathode. So based on this you have to remember. Cell, however it is drawn, you have to mention or represent it in this way. We have two aspects, that is qualitative and quantitative. So qualitative aspects, it depends on the electrolyte used, correct. Always the electrolyte should be in the liquid form, correct. We can also write it as it should be in the molten form, it should be in the aqueous form, correct. It can also be in the ethereal form. That means dissolved in ether, dissolved in water. If you add water, it becomes the aqueous form. If you melt it, it becomes a molten form. If you dissolve it in ether, it becomes ethereal form. So the electrolyte has to be in the molten form. Now what is a medium? The second is medium. So that is what we discussed this all. Like the molten form, aqueous form, ethereal form, correct, medium, how it should be. And the third one, that is about the electrode. The electrode can be platinum or any active metal copper. Platinum, it is inert in nature, so if we are using a platinum electrode means it will not take part in the reaction, correct, when electrolysis takes place, when splitting of the electrolyte takes place. But when copper you are using, that will also take part in the reaction, right. So liquid, three aspects in qualitative. Main thing, the electrolyte should be, what medium of the electrolyte should be in the liquid form, that means it should be in the molten, aqueous or ethereal form. The electrode can be inert or it can be any active metal, right? And moreover, qualitative aspect we will also study what are the products at cathode and anode. It depends on the medium. It depends on whether the medium it is molten, aqueous or ethereal. Based on that we can also find whether the product at the anode is what and what is the product at the cathode. What product? Okay. Next is a quantitative aspect. Quantity, right? So we can identify, or using this aspect, 4 things are there. One is W. How much weight has been deposited on the electrode? How much volume of electrolyte is taken, or how much volume has been deposited? Then I, how much current is passed through the circuit, and T, how much time was the current passed, or how long did it take for the substances to get deposited on cathode and anode. So qualitative, we will find what products are formed at anode and cathode, and quantitative, we will know the quantity of substances deposited, how much time the current was passed. First we will start with the qualitative aspects. Qualitative means what product is formed at anode and what is the product at cathode. Okay. So a simple example we will take sodium chloride, which is in the molten form, right? As I told you, the electrolyte has to be in the molten form, in aqueous form or in ethereal form. Okay. So this is in the molten form. Molten means what? It is melted, right? That means no water is used here. So NaCl alone, it is melted. Okay. So if the electricity passes, it forms Na plus and Cl minus in the electrolytic cell. So Na plus will move towards cathode because it is negative electrode, and Cl minus will move towards anode because it is positive electrode, right? Now let's write the reactions over here. Reaction at anode and reaction at cathode. Earlier also I have written, once more I will write it. Reaction at anode, that is oxidation. So oxidation, loss of electrons, Cl minus, Cl2 and electrons. Loss of electrons on the right hand side. Cl2, we don't write Cl alone. Reduction at cathode, so cathodic equation will be Na plus is going towards cathode, gain of electrons, and it reduces to Na. So what are the products at anode and cathode? The product at anode, that is which undergoes oxidation, anode it is Cl2, chlorine gas, and at cathode the product is sodium. Correct? So if the electrolyte it is in the molten form, it is easy for you to identify which product is formed at cathode and what product is formed at anode, right? If the electrolyte it is in the molten form. Now suppose if the electrolyte it is in aqueous form. Suppose I write here NaCl aqueous, correct? Aqueous we write it in short as AQ, aqueous form. Then again it will split into Na plus Cl minus, but this time aqueous means water. Water also has H plus ions and OH minus ion. So you can see here we are getting 2 cations and 2 anions, right? So out of this 4, what will be the product at anode and what will be the product at cathode? That we have to find. So this is what we study in qualitative analysis. What are the products formed at the electrodes? So if the electrolyte it is in the molten form, it is easy to recognize what is the product formed. But if the electrolyte it is in the aqueous form, that means water is also present, which consists of H plus ions and OH minus ions. So how to find what is the product if the electrolyte it is in the aqueous form? For this, we have a series which is called as the spectrochemical series, which we will discuss in the next video. Thank you all for watching this video.